Number 52, calculate the number of moles and the mass of the solute in each of the following solutions, and then we have letter A. So in this case, we need to find the moles and the mass of 325 mils, or milliliters, of an 8.23 times 10 to the negative fifth molarity of Ki. And potassium iodine, Ki, is a source of iodine in the diet. Okay, so here's just a salt, potassium iodine, that we have in our diet. Okay, so we just need to find the number of moles and the mass of what they gave us. Now, they gave us a volume, right? Milliliters is a type of volume. They gave us a molarity. So we should be thinking of a relationship between molarity and volume and definitely the moles or the mass, right? Now, there's a formula, but I want to give this to you in a different way, right? And that's using this very handy-dandy triangle right here. So your triangle, if you write it down, doesn't have to be as pretty as mine, right? But you can make it, pretty, use your colors. But the only thing that matters is that you need to draw a triangle, right? You need to put like this T down the middle. And then you divide the three sections up into molarity, and it has to be on this box. Moles are always at the top, and liters. These are the only three units that are related to each other when we talk about molarity, right? So molarity is related to the amount of moles a solute, right? And it's the liters of solution. So let's see, what did they give us? Well, they gave us 8.23 times 10 to the negative fifth molarity. Capital M is a molarity value. So I have my molarity. And they gave us 325 milliliters, right? But in order to use this little triangle here, I need to have liters. So the first thing that I'm going to do is I need to convert the 325 milliliters into liters. Now this is going way back, right? Way back into the chemistry course. But I gave you a little trick down at the bottom. If you need to convert milliliters to liters or liters to milliliters, just know that the number to go back and forth is 1,000. In this case, we're starting at milliliters and we have to get to liters. So I'm going this way. So you take your milliliters and all you got to do is just divide by 1,000. So I could take my 325 and divide it by 1,000. Similarly, you can just find the decimal, right? The decimal would be here. And you just go 3 spots to the left and make your new decimal. Either way, it's the same exact thing. So here, I now will have 0.325 liters. 325 milliliters is equivalent to 0.325 liters. And now I have this part. Now I know that I have two values, right? So I can search for the other one. And look, they wanted to know the moles. So that's what I'm going to find. But now I just need to write the formula. Well, that's the beauty of using this triangle. You put down what you're searching for, right? So in this case, we want to find out how many moles of the solute are here. So if I'm searching for it, I will, if you're using paper, right, or if you drew it yourself, hover over the unit that you're looking for. So in this case, if you hover over moles, you won't see it anymore. And now you're down to just these two units. Since they are on the same block, right, they're on the same line, right, one's not on top of the other, this indicates that you have to multiply. Same block is multiplication, but if you had to go up or down, it's division. Think of this line as like a division line, right? But in this case, moles will equal molarity times liters. And now all I got to do is just solve, right? So moles of my solute, which is potassium iodide, will be the molarity. And the molarity they told us was 8.23 times 10 to the negative fifth. And then my liters is the 0.325. So let's calculate how many moles of the solute, and in this case it would be Ki, right? So the moles would be 8.23 times 10 to the negative fifth times 0.325. 3 sig figs if you want to round. So it would be 2.67 times 10 to the negative fifth. And that's the unit of moles. Okay, we got one part of the question already. We found out the number of moles of the solute. I have a very, very, very small amount of moles in this solution. Only 2.67 times 10 to the negative fifth. So that's done. Now I just have to go and find the mass, right? And a mass is in grams. So I have a quantity, I have the moles. I can convert to mass or grams, right? This is going way back as well. Here's a little trick, right? If you're starting off with moles of anything, it's just an element or a compound, and you want to find the mass in grams of that same thing, right? All you got to do is take your moles, this is what you start with, and you multiply by your molecular weight, right? You see that we're going this way to get to grams? And remember, the molecular weight is the same thing as a molar mass or a molecular mass. This is all found on the periodic table. So we have to find out what the molecular mass is, or the molar weight, of potassium iodine. So we just got to do a little side section. Let's find that molecular weight of Ki. We've done tons of these problems, right? So let's see if your number matches mine. We have 1 potassium, 1 iodine. So I'm just going to add those two together that I see on the periodic table. 39.1 for potassium, and iodine is 126.9. So I get 166 grams per mole. That's the molecular weight. So now I'm just going to take the moles that I found, this number, and times it by the molecular weight, and I will get my grams. So let's do it. 2.67 times 10 to the negative fifth times, and maybe I'll do that in a different color, times the molecular weight, so 166, and that will equal the grams that I have. Now, if we keep the units here, right, this was in moles, and this is molar weight is in grams per mole, right? G over M, right? Grams over mole. And look what happens. The mole cancels out with the mole, and that's why you only have grams left. So let's just do this multiplication. 2.67 times 10 to the negative fifth times 166. And we get roughly 0.00443. And that's grams of potassium iodine. If you want to convert this into scientific notation, that's perfect as well. It would be, if we just move the decimal place, right, we would go 1, 2, 3 over. So this is the same thing as 4.43 times 10 to the negative third grams. So either or, it's the same answer. And that's it. Guys, what do you think? I think this chart helps. The triangle chart, right? So just memorize it and make sure that it's molarity, liter, mole, okay, for it to work. So yeah, thanks for tuning in. Let me know in the comments what you think. If you want, you can subscribe to the channel. It will help us out. And I hope you guys are having a great day. Keep studying hard. I'll see you in the next lesson. Bye-bye.